All right, this is time for the fifth type of chemical reaction that you learned. So far, again, we've learned combination synthesis, where we take two elements, put them together. We did decomposition, where we take them, tear them apart. We did single replacement, where we have one element that goes in and takes the place of another element that's part of a compound that has two or more. And then we did double replacement, where we get the two positives trade places and make new compounds. Now we're to the fifth one, which happens to be called combustion reactions. And in the case of combustion reactions, what we're actually doing is we are burning a hydrocarbon. All right, exactly what the word is. The word combustion means to burn. Oops. Ignore the noise in the background, but so we're burning a hydrocarbon, what is a hydrocarbon? A hydrocarbon is anything that contains exactly what the word says, hydrogen, carbon. It's got to have carbon and hydrogen inside of it. It can also have oxygen, but at least it's got to have carbon and hydrogen as part of it. All right. So we're burning that, but it's also got to be in the presence of oxygen, which takes us all the way back to the very beginning of this course when we talked about in order to make something burn, you got to have oxygen, you got to have fuel, and you got to have heat. So we got to have oxygen in order to make that thing burn. So basically, we're always going to do we're always going to take that hydrocarbon, we're going to combine it with oxygen. And then the awesome piece on this, because we are completely combusting it, we're burning every single piece of it, we are always going to end up with carbon dioxide and water. That's all. We're always going to get that. This one I like to think is the easiest one to write because everything's the same except for the hydrocarbon at the beginning. All right. Now, I will tell you the one bad part is they're usually really big when it comes to balancing them. It takes lots and lots and lots of circles in order to get them to balance. But they are the easiest ones to write. So let's start with the first one. We've got on the homework, or not homework, but the notes. We got this. Is that a hydrocarbon? Yep, sure is. It's got hydrogen, it's got carbon. It also has some oxygen with it too, but it is a hydrocarbon because it contains carbon and hydrogen. We're going to completely combust this, so we're going to combine it with oxygen. All right, and then because we're completely combusting it, it always makes CO2 and H2O. Always. They always make that. So again, everything on these reactions are the same. They're always going to have plus O2, forms CO2 plus H2O. Those three spots are always going to be the same. The only thing that's going to change is that first one. And if you look in your notes, you'll notice that all four of them that I gave you, it's the first thing that changes in all of them. Everything else was exactly the same. All right, so based on that, now all we got to do is balance it because there's nothing else to do. We don't have to like put anything together or anything like that. So we're going to make our circle. So this one's kind of big. There's 6 C's, and we got 12 H's. There's 4. There's 8. There's 12, and then 6 O's. Plus we got 2 O's. And that's got to be equal to a C and 2 O's plus 2 H's and an O. All right, so again, start with the elements. First element all the way over to the left, leave hydrogen, oxygen to the last. So the only other element that's on here is carbon. So we're going to start with the carbon. 1, 2, 3, 4, 5, 6. I only got 1. So I need to get some more of these. There's 2. There's 3. There's 4. 5. There's 6. So there's 6 C's. All right, well, let's do H's next. H, I got 12 of them. I only got 2, so I need some more of these. There's 4. There's 6. 8. 10. 12. So there's 12 of them. All right. So now I've got 12 C's, 12 H, or I got 6 C's, 12 H's. Now I'm up to my O's. So if I do my O's, I've got 1, 2, 3, 4, 5, 6, 7, 8. On this side, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18. That's a weird number. But now you gotta remember, if I add any more to this guy, that's gonna mess up all my C's and O's. So I need 18, but let's see if we take the 18, get rid of these 3 off of that, or those 6, I mean. So 18 minus 6 leaves me with 12 more. Can I get 12 more here? So there's 2, there's 4, there's 6, 8, 10, 12. So now how many does that give me total on this side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's what I needed. All right, so now all I gotta do is go back through and put in my numbers. I got one circle of that, leave it blank. 6 of this guy, 6 of that guy, and 6 of this guy. All right. Now, what is this reaction? This reaction is actually, if you remember from biology, this happens to be cellular respiration. This right here, that's glucose or sugar. And then we breathe in oxygen. We take in oxygen. And then what we do is we take that oxygen and we burn the sugar inside of us. And when we burn something, usually what do we get out of it? Heat. So our body gets some heat out of that. Well, not some, we get a lot of heat out of that sugar that we burn to keep our body temperature up to that 98.6. And then because we're burning it, we're giving off carbon dioxide and we're giving off water. So I actually know that I am completely combusting this hydrocarbon sugar because I'm breathing in oxygen and because I'm giving off carbon dioxide and I'm giving off water. There's the key thing right there, because I'm giving off carbon dioxide and water, right? It's not really just because I'm breathing in oxygen, right? You don't have to completely combust something just because you get oxygen. The key thing is because we end up with this, right? Another hydrocarbon that's out there that would be great if we could completely combust it is gasoline that we put in our cars. It's also a hydrocarbon. We do combine oxygen to it inside of our motor. The only bad part is we don't completely combust it, because the stuff that comes out of the tailpipe is not carbon dioxide and water. It's actually carbon monoxide, and a whole bunch of other stuff. Okay? It'd be great if we could get it to the point where we burn every single piece of it and get all the energy out of it, and we'd get great gas mileage in our cars. We haven't got to that ability. But I also like to note that our body is extremely efficient, because we get every piece of energy out of that thing when we burn it up, because we're completely combusting. We don't breathe out carbon monoxide, we breathe out carbon dioxide. All right, so that's the first one. Let's do the second one. And let's see, I only have to erase a few things here, because remember, all the rest of this stuff stays exactly the same. All right, so we're doing C8, H18 plus O2 forms CO2 plus H2O. This one actually is a thing called octane. And next time you go to the gas station, notice that on the gas tank pump, it talks about there's 3 different buttons to push. You can push the cheap one, the mid-grade, or premium. And if you look at it, it says it has different octane ratings as to how much of this stuff is actually inside the gasoline to burn, right? But that's what octane is, and that's what we burn inside of our cars, and then we have to combine it with oxygen. Now again, we wish our cars were did complete combustion, so we give off these two, but our car doesn't do that. It doesn't make it to that point. But we try and do it by putting more and more oxygen. We try and push oxygen into it by using things like turbos. We use blowers on motors in order to try and push more oxygen down into the motor to try and increase that oxygen rate. And if we can get more energy out of that octane that we happen to use. So, all right, well, let's do this one. It's already written out. Now all we gotta do is balance it. So this guy over here, I'm gonna show you a little different way of doing this one. You don't have to do it this way, but you can do the bubbles, but I just wanna show you a different way of doing this. One way is we got carbon on both sides. On this side we have 8. On this side I have 1. Well, that's not even, so what I need to do is put an 8 in front of this. Now it goes 8 times 1. This is now 8. So that makes that even. Then I go to H's. I got 18 on that side. On the other side, I got 2. So I need to put a 9 in front of this. Go 9 times 2 makes this one 18. Now I get to my oxygens. On this side I got 2. The other side I got 8 times 2, that's 16. Plus I got 9 times 1, that's 9. Add those two together, that's 25. Can I get this over here to ever become 25? Nope, it's never going to happen. So if you remember way back when, I told you if you ended up with an even and an odd number, then what do? Well, you go back to this first one and double it. So I'm going to put a 2 out in front, and then we got to start all over again. So I start all over, and now I'm going to do it in red instead now. So I got to go, carbon's 2 times 8, that is now 16. So I got to change this number. This is where it becomes a it's not very easy because you have to erase things. But so I need to put 16 in front of it. 16 times 1, that's 16. And I do my H's. Well, 2 times 18, that's 36 of them. So on this side, I got to change this. It's got to become an 18. 18 times 2, that's now 36. Then I do my O's. I still got 2 on this side. But this side over here, I got 16 times 2. This is gone. I got 32 plus 18 times 1. It's 18. That's 50. So how many of these guys over here do I need? I need 25 of them. I need 25 O's in there to get that octane to burn entirely. Right? And this is again why I told you earlier. And if you like to work on cars like I do a little bit, I don't do a crazy amount, but I do some. And that is, if you really want to get some major horsepower out of a motor, then you need to add a turbo to it. And a turbo, what it's going to do is it's going to force more oxygen into that into the motor to try and burn more of that octane and get greater amounts of energy out of it. Or you can do like in the movie Fast and Furious, and you got the one guy that's on there. He's got the black car, got the thing that's sticking out of the top of the hood, and there's a little belt that goes around it, and then he pulls a wheelie with his car. That's a blower. All right, and what it does when the belt turns on, it actually takes the air and pushes that down inside the motor to get more oxygen in there to try and get closer to that 25 and get more energy out of it to increase the horsepower on that motor. All right, so again, that's just some ways in which we can relate this to real life. Now, this system here, if you were confused on what I did, you can still do it with the bubble system. That bubble system will work. I just wanted to show you this because some teachers only like to use this one. My problem with this one is it can be confusing because you got to remember that this 16 applies to both of those, and that 18 applies to both of those, and that's some of the mistakes that can happen periodically when you do this one versus the bubbles. So you can always do the bubbles; it'll work all the time. But all right, well, let's move on to the next one. Which, looking at my time, I'm going to switch to part number 2 now to do the next two.